Hello and welcome to this tutorial on understanding powers and roots. When we are talking about powers, we're also referring to what is also known as indices. And these refer to when I have 4 to the power of 3, 5 to the power of 2, or 10 to the power of 4. The powers refer to these numbers here. And these numbers here tell us how many times we are going to multiply the base number by itself. So here, this is what we refer to as the power or indice, and this number here is what we refer to as the base. So this bit highlighted is the power indice and this bit below it is the base. Now what the power dictates how many times we're multiplying together the base number. So if we've got here 4 to the power of 3, this is going to equal 4 times 4 times 4. Okay, because what we've got to do is we've got to multiply 4 together 3 times. We also refer to 3 times as being cubed. You might have heard of that before, and you might recognise it from the term centimetres cubed. And the reason why we call it centimetres cubed is because there's 3 dimensions. If you think about a centimetre is a length, then we have a centimetre square, then we have a centimetre cube. And so when we have the centimetre cube, we have got 3 dimensions. We've got the length, the width, and the height. And the way that we calculate volume is by length, width times height. So that's where the cube comes from, because we're multiplying something by itself 3 times. Following from that, we've got this here, the 5 squared. So the 5 squared means 5 times 5. And if you think about a square, the way that you find the area of a square, so say for example that's 1, is by doing length times width. So that would be 1 times 1, which would give us the area of the square. So in a way, these things make a bit of sense. So 5 to the power of 2 means 5 times 5. However, we go beyond that because we end up with indices such as to the power of 4 or larger sometimes. In the future, we're going to be looking at a topic called standard form where the powers get pretty high. So it's important that we know what this means. But if we had 10 to the power of 4, what this refers to is 10 times 10 times 10 times 10. So obviously we can calculate these using our calculator. 4 times 4 times 4, well 4 cubed is 4 times 4 times 4, and that's going to equal 64. 5 times 5 equals 25, and 10 times 10 times 10 times 10 equals 1 and 4 zeros, which we'd call 10,000. So the thing to remember is that if you see this written down here, this thing, 4 cubed, that means 64. They have the same value. If you see 5 squared, that means 25. If you see 10 to the power of 4, that means 10,000. Okay, so let's have a quick look at what these might be. So 6 to the power of 7 is going to be 6 multiplied by itself 7 times. So we could have 6 times 6 times 6 times 6 times 6 times 6, 1, 2, 3, 4, 5, 6 times 6. Now, I'm going to do that on my calculator. Now, on my calculator, I'm going to use a button to help me put the power up to the top. So you'll see it on your calculator. It's a button, and it's got here it's X, and it's got a little square above it. So what I'll do here is I'm going to do 6 to the power of 7, and that's going to equal 279,936. And I'm going to put a comma there so I can make it easier to read that number. So this number is 276,936. So if you ever see 6 to the power of 7, that is going to be referring to this number. And the way that we'll have calculated that is by doing 6 multiplied by itself 7 times. Now let's have a go at 8 to the power of 3. So remember 8 to the power of 3 means 8 cubed, which will be 8 times 8 times 8. And then I'm going to do that on my calculator again. 8 to the power of 3. And that equals 512. So if you see 8 cubed means 512. Okay, so those two numbers have the same value. Right, 7 to the power of 5. Have a quick think how you're going to work it out. What we're going to do is we're going to do 7 times 7 times 7 times 7 times 7. 1, 2, 3, 4, 5. And again, I will do that on my calculator. I can either type in 7 times 7 times 7 times 7 times 7, or I can do 7 to the power of 5, which is probably what I'm going to do. 7 to the power of 5, and that equals 16807, and which we'll call that 16,807. So here we go, and here we go. Right, so that is powers covered. Now what we've got to look at is roots. Now, roots are our means of undoing a power. So in a way, they're kind of like our reverse calculation for when we square something, cube something, put something to the power of 4, 5, 6, whatever. So say, for example, I do 5 squared. I know that 5 squared is 25 because it's 5 times 5, which equals 25. Let's say I wanted to know what base this had, and I wanted to go back from here to here. So what I can do is if I've got 5 squared equals 25, I know that the square root of 25 will equal 5. So if you see this symbol here, this symbol is called the square root sign. And essentially it undoes the calculation to get it back to where it was. So if 5 squared equals 25, the square root of 25 equals 5. So let's have a look at some more square numbers. So if I have 1 squared equals 1 times 1, okay, that equals 1. Okay, so if 1 squared equals 1, I know that the square root of 1 will equal 1. Okay, 2 squared equals 2 times 2, which equals 4. So the square root of 4 will equal 2. 3 squared equals 3 times 3, which is 9. So the square root of 9 will equal 3. 4 squared equals 4 times 4, which equals 16. So the square root of 16 will equal 4. 5 squared equals 5 times 5. So the square root of that, which is 25, and the square root of 25 equals 5. In GCSE Maths, you are required to actually know all of the square numbers and all of their square roots up to 10 squared. So what I'm going to do is I'm going to continue to go through these, and if you want to pause this page to have a quick go at memorising these, it will be worthwhile. But I'm now going to move on and look at the higher roots. So what we continue to have is we'd have 6 squared equals 6 times 6, which is 36. So the square root of 36 equals 6. 7 times 7, 7 squared is 7 times 7, which equals 49. So the square root of 49 equals 7. 8 squared equals 8 times 8, which is 64. So the square root of 64 equals 8. 9 squared equals 9 times 9, which equals 81. So the square root of 81 equals 9. 10 squared equals 10 times 10, which equals 100. And the square root of 100 is equal to 10. Okay, so these things here are our square numbers, and these are their roots. So 36 is a square number, 6 is its root. 49 is a square number, 7 is its square root. 64 is a square number, 8 is its square root. 81 is a square number, 9 is its square root. 100 is a square number, and 10 is its square root. Okay, let's now have a look at cube roots. Say for example, I had 2 cubed. Well, 2 cubed is 2 times 2 times 2, and that equals 8. Now, if I want to get back to the 2, what I need to do for this one is I use a thing called the cube root. So the cube root of 8 would be 2. Now, you can find your cube root button on your calculator. It is just above the square root button. So if you want to test this out, if you press Shift, square root button, you should see that you get the root sign with a little 3. And then in the root, you can put 8, and you'll find that that will be equal to 2. Okay, let's try a different one. So let's say we could have, well, let's go for 3 cubed. So 3 cubed will equal 3 times 3 times 3. And that will equal 27. And then we can get the cube root of 27. So the cube root of 27 here. And that will take us back to 3. Let's do one more cube and then I'll change the power again. Let's do 5 cubed. So 5 cubed will be 5 times 5 times 5, and that equals 125. So the cube root of 125 will equal 5. So the cube root of 125 will equal 5, and we can test that on the calculator by doing Shift square root sign 125 equals, and that gives us 5. Right, so these here, with this little 3, this is called the cube root. When we don't have any sign, it's called the square root. When we have the little 3, it's called the cube root. Now let's look at the 4th root. After 3, they lose their snazzy names. So let's say if I had 10 to the power of 4, we looked at it before. So if I had 10 to the power of 4, I know that 10 to the power of 4 is 10 times 10 times 10 times 10. So that equals 1 and 4 zeros, which is 10,000. So if I've got 10 to the power of 4 is 10,000, I could then do the 4th root of 10,000, and that would equal 10. So what we're doing is the root always takes us back to the number we started with. So if you do 10 to the power of 4 and then find the 4th root of that, that undoes it. Okay, so it's like our reverse calculations again. So let's say we've got a different one. Let's say this time we've got 7 to the power of 4. So 7 to the power of 4 would be 7 times 7 times 7 times 7. I'll have to do that on my calculator because I don't know that one. 7 times 7 times 7 times 7. So that equals 2,401. Now if on our calculator we do the 4th root of 2,401, this should equal 7. So let's test that out. Now, if you want to find any root, okay, the button, if you've got the same calculator as me, is you press Shift and then you press the X, the button which has an X and a little box by it, and then you get a tick like this, and you'll be able to do whatever you like with that. So I'm going to put a 4 in the little box, and then I'm going to put 2401 here, and that equals 7. So that is correct. So, so again, what we get is the power of 4 root is the way that we undo it. So again, let's just recap. We can have the square root, which just looks like this. We can have the cube root when we've got a 3. And we can have the 4th root when we've got a little 4. We can also have the 5th root, the 6th root, the 7th root, the 8th root, the 9th root, and so on. You get the idea. And each time, these root signs just undo what the power has done. So, yeah. Great, right. Now that we've done those, let's go have a look at some questions. So let's have a look at question 1. And question 1 says, calculate 4 squared. So what we've got to do is we've got to remember that 4 squared is equal to 4 times 4. Okay, so that's what the power of 2 means. So 4 to the power of 2 means we multiply the 4 by itself twice. And that will equal 16. Let's have a look at another one. Okay, so let's have a look at this question here. It's question 7. And it says simplify 2 to the power of 2 all to the power of 3. So what this actually means this time is we've got 2 squared. Now, when we look at these, we've kind of got to remember our brackets, okay? So what this means is we've got 2 squared, which means 2 to the power of 2. So what this means is we've got 2 times 2 all to the power of 3. Now remember, to the power of 3 means we multiply by ourselves 3 times. So this will mean 2 times 2, bracket, bracket, times 2 times 2, times 2 times 2. So here we go. This is 2 to the power of 2, all to the power of 3, which becomes 2 times 2 to the power of 3, which becomes 2 times 2, times 2 times 2, times 2 times 2, because we're multiplying it by itself 3 times. And so this is actually going to equal 2 to the power of 6. So there we go, that is that simplified. And actually, as that is a bit of a different skill, I am going to have a go at another question like that. So this question doesn't exist on the sheet, but what I'd like us to do is I'd like us to have a go at this question here, which is simplify 3 squared to the power of 5. So here we've got to simplify 3 squared to the power of 5. So 3 squared, again, will mean 3 times 3. So what we have here is we've got 3 times 3 to the power of 5, which means 5 lots of this times itself. So this is going to be 3 times 3 for one time, 3 times 3 for another time, 3 times 3 for another time, 3 times 3 for the fourth time, and times 3 times 3 for the fifth time. So what we then get is we've got 3 being multiplied by itself 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times, okay? So this will simplify to 3 to the power of 10. Now, I didn't point it out, but in the last time, what you might notice is that in order to simplify this quickly, we can multiply these powers together, because 2 times the 5 is the 10. Okay, let's do one more of these, and then I'm going to do one more question from the practice list, and then we'll look at the scenario section. So here we go. Let's have a go at simplifying 2 to the 3 all to the power of 4. So this time we've got 2 to the power of 3 all to the power of 4. So remember, there is a quick way. If you remember the quick way, you can do it. If not, I'm just going to go through the long way so that you can remember the way to do it in the way that makes sense with indices. So here we go. 2 to the power of 3 all to the power of 4 will be 2 times 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 2. And what that gives us is that gives us 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that equals 2 to the power of 12. And remember, if you did spot it, 12 does happen to be 3 times 4. So remember that rule. If you get an indice inside a bracket to the power of another indice, you can just multiply those things together in order to get your final answer. Okay, here we go. Let's have a look at this question. This is question 9, and it says solve x squared equals 49. So this is going to be a case where we want to use our square root sign, because what we know is that some number multiplied by itself equals 49. So we need to reverse that operation. So in order to find x, we're going to have to find the square root of 49. Now the square root of 49 we can do on the calculator. So square root of 49, and we can see that that equals 7. And there we go. Right, let's take a look at some of the scenario questions. Okay, here we go. We've got question 1 from the scenario section, and it says a square has an area of 36 centimeters squared. Find its side length. Okay, right. So what this requires us to do is requires us to remember the formula for the area of a square. So if I think about a square, here we go. The area of a square, well, squares are unique because their sides are all the same length. So if we let's call it x. So in order to find the area of the square, we would do side times side, which we could also think of actually being side squared. So we know that the area of a square is given by the side length squared. Okay, so if the side length squared equals 36 centimeters squared, now if we want to find the side, we need to go from the square number back to its root. So we're going to need to find the square root of 36. So if the side squared equals 36, the side will equal the square root of 36, and the square root of 36 is equal to 6. So there we go. So we've moved from the square number back to the square root. Right, let's have a look at question 2. Okay, so question 2 here says, a football pitch is 100 metres by 100 metres. Express its area as a power of 10. Okay, so from this, what we're going to have to assume is that the area of the football pitch, we're assuming it's a rectangle here, well, a square, a bit of a funny, in fact, a massive football pitch, just in a weird shape. So we're assuming that the area of the football pitch is in a square, and it's 100 times 100. Okay, they want its area as a power of 10. Okay, so remember the area of a square is side times side. So in this case, what we've got is we've got 100 times 100. Now we've got options here. What we can do is we could either just multiply this all together and think about this as being 10,000, and then try to think about what this would be as a power of 10. Or we can break down these hundreds actually, because we might know already that these hundreds are actually both 10 times 10 in themselves. So what we've got here is 100 breaks down to 10 times 10. 100 breaks down to 10 times 10. So the area of this football pitch, which is 100 times 100, is actually the same as 10 times 10 times 10 times 10. And this is going to equal 10 to the power of 4. Now, this topic here is much more featured in a future video on standard form. So if you want more practice at this sort of thing, I would also visit that tutorial. But this is a classic question when this sort of thing is only ever really going to be asked to you with powers of 10. Okay, well, I think that's quite a few examples done. I hope that's been useful for you. And remember, there's loads more practice available at crackmaths.co.uk. And this was tutorial 74. Okay, so hopefully see you in another tutorial soon.